The topic that will be covered is circular motion. Here is a problem we will be focusing on to go over this concept. In a motorcycle race, a motorcyclist is moving in a circular track at a constant velocity from point A towards the direction of the arrow provided in the image below. Assume the ground is frictionless. What forces are acted on the moving bike? Choose the correct answers. Choice A, Fg and Fn. Choice B, force from A to B. Choice C, force from B to A. Or choice D, force pointing in direction of motion. The principle that we will be using for this problem is F net equals mass times the centripetal acceleration. The justification we'll be using is Newton's second law, which will sum up all the forces acting on one object. AC means the object is moving in a circle, and our acceleration will be 0 because the velocity is constant. We will now tell you the solution to the question and explain why some of the options are correct and why some are incorrect. For the correct answers, choices A and B are correct. Choice A is chosen because Fn is the force that keeps the object up. Fg is there because there's always gravity on the object due to the Earth. Fnet in the y direction is 0, therefore Fn equals Fg. Choice B is correct because there is a centripetal force. This force keeps the object moving in a circular motion because its direction always directs to a fixed central point in a circle. There's also an inertial force that resists the change in velocity. Choices C and D are incorrect. Choice C is incorrect because this force is not an inertial force because it doesn't resist the object's velocity since it's not touching the object. The misconception to this is that people usually think that there should be another force acting on the object besides the centripetal acceleration Fg and Fn to keep the bike from falling. However, the B to A force does not act on the object. For example, people usually think that when they make sharp turns in a moving vehicle, there is a force that points outward to keep them from falling inward. Choice D is incorrect because the object has its own velocity. There are no other forces touching the object to keep it from moving. The misconception of this is that people usually think if an object is moving, there should be a force that touches it to keep it from moving. This is not the case. For example, a kid initially exerts a force to a toy car at rest to make it move. After the kid lets go, the kid no longer has an influence on the toy car. In conclusion, this video went over the concept of circular motion. After this, you will have learned that when an object moves in a circular motion, only the forces of Fn, Fg, and centripetal force was experienced. The misconceptions of this was also covered. People usually think that there is a force from the center of the circle towards the object, and a force pointing in the direction of motion. This, however, is false. We use Newton's second law to help us justify our reasoning. That is the end of this lesson. Thank you for your time. This project was inspired by a presentation from Kelsey Stewart.